I am taking RL circuit and then RC circuit. XL by R, XC by R. So I asked you to remember the elements resistor and inductor in the circuit. We have supply voltage and current. Okay. So V of t is the supply voltage, current I of t in the circuit, and R L. Okay. So Z is nothing but real plus imaginary. Z is nothing but real plus imaginary. The angle between, okay, angle between R and Z is nothing but tan inverse XL by R. So which is tan inverse XL means omega L by R, and omega means 2 pi F L by R. In the question, they will give the values of F, L, R. Okay. Now, the same angle is valid between the current and voltage in the circuit. Angle between V of t and I of t in the circuit is also, okay. So, tan inverse XL by R. This is called phasor angle theta. Angle is theta equal to, this is the theta value. This is the theta value. Okay. Left side I have done with RL circuit. This is RL circuit. What we have done? Angle theta between voltage and current. V of t and I of t. Okay. Now right side I will go with RC circuit. You have to remember very simple formulas. Very simple formulas. Equation 1 is the formula. The same equation 1 is here. Okay. Equation 1 is the formula in the entire discussion till now. Now I will take up RC circuit and I will deal with the angle between voltage and current in RC circuit. Okay. Voltage and current in RC circuit. All these are part of the phasor diagram. Phasor means angle difference. Now I am going with a supply voltage, resistor is present and a capacitor is present in the circuit. This is capacitor C, current I of t in the circuit, voltage V of t for the circuit, R and C are the components. Now Z, the complex variable is R minus JXC, R minus JXC. And now angle between R and Z is nothing but theta equal to tan inverse XC by R. XC means 1 by omega C. XC means 1 by omega C. And omega means 2 pi F. Tan inverse 1 by 2 pi F into C. Omega value is 2 pi F. Okay, CR always exists. The same angle exists between voltage and current in the circuit. Voltage in the current in the circuit is also same formula, tan inverse XC by R. Okay. If you see RL RC circuit, if you write minimum information like this slide what I have written, okay, entirely you by heart. Whenever you see phasor diagram, RL circuit, RC circuit, you write this circuit and equations, okay, you will get some marks. This is same, equation 1, equation 1, or I will write 2. Equation 2 is for RC circuit, equation 1 is for RL circuit, okay. And other than this, we have seen one diagram also, phasor diagram, between the RZ value, okay. So now this is the phasor diagram. R will be taken on x-axis, and JXL is the imaginary part, and this is the hypotenuse, this is the Z value, and this is the angle between them. This is the angle between them. X-axis, y-axis is arrow mark given. On x-axis, real part is taken. Okay, on x-axis, real part is taken. So if you see here, this is the real part. Okay, and this is imaginary. Capacitor and inductor will give always imaginary. This information you write in the answer paper. Phasor diagrams, heading is phasor diagrams. So x-axis, y-axis, And now I am dealing with RC circuit. So you have to go with negative y-axis also. R will come on positive x-axis. Minus jxc will come on fourth quadrant. Now this is the hypotenuse z value. This is the hypotenuse z value. This is the angle between them. Okay. This is called phasor diagram. This is called phasor diagram. This is circuit diagram. This is phasor diagram. Okay. And phasor diagram for RL circuit. Now right side it is RC circuit. RC circuit. This is the basic circuit diagram. And this is the phasor diagram. Phasor diagram. Okay. The topic is third unit phasor diagrams. Now I will tell you some more information. If we have two sine waves, if we have, let us assume 3 sine waves. So this is sine wave A. White color is A. Now I am drawing one more wave with some delay. Okay, this yellow color is capital B. And I will draw one more waveform C, which will start before origin. This third diagram starts before origin. Blue color waveform before origin. Okay, this is C. If you observe these 3 diagrams, C is starting before origin, A is starting at origin, B is starting after origin. Okay, so here B lags A, and then C leads A, and then these are the 2 main things you have to remember. Other than this, A lags C also we can say, B lags C also we can say, and then C leads B also we can say. These are additional informations. These are additional informations. But you have to remember these 2 statements. Okay, you have to remember these 2 statements. B is starting late after origin, yellow color. B is starting late. So it is said to be lag. Okay, B is said to be lagging. B is said to be lagging. Okay, and C is starting before origin, before A. A is starting at origin. So C is starting before origin. So it is said to be leading. Okay, and in terms of equation, if you write, in terms of equations, if you write, okay, in terms of equations, if you write, if you say A equal to 10 sine omega t, okay, then we have to say B is 10 sine omega t minus theta 1. This theta 1 is the lagging factor. Okay, so theta 1 is the lag. Okay, angle, phase lag. So we can tell it is the phase lag. Now similarly C, it is leading. We are telling leading, no? So 10 sine omega t plus theta 2, because all the 3 waveforms are of same height. So I am taking 10 amplitude common for all the white, yellow and blue color waveforms. Now 10 sine omega t plus theta. Now this theta 2 is the phase lead. Okay, how much angle it is leading, that phase lead is theta 2. We cannot say both of them are lead and lag is of same angle. Okay, that's why I am taking different representations. That's the reason I am taking different representations. So theta 1 and theta 2. So minus means we are calling it as lag. So plus means we are calling it as lead. Okay, you remember. So minus means lag and plus means lead. It is called as lead. This is in terms of equations. In terms of equations, you can see in terms of waveform. You remember in terms of waveform how they are starting. In terms of equations, how we have to write them. Okay. So now I will go with some information from the textbook material. So if you get some problems, you will be able to do if you remember this second slide, what I discussed in the second slide. You see here, here angle 30 degrees. Okay, 30 anti-clockwise. Anti-clockwise angle measurement are positive. Clockwise angle measurement are negative. That you already know. This is about the anti-clockwise measurement. If it crosses 90 degrees, it is in the second quadrant. If it crosses 180 degrees, it is in the third quadrant. Okay. If it crosses 270 degrees, it will come in the fourth quadrant. All these are anti-clockwise measurement. Clockwise means it is negative angle. You see here clockwise angle mentioned. Clockwise angle mentioned. Here also clockwise angle mentioned. It is minus 225. Anti-clockwise means plus 135. And clockwise measurement, it is minus 225. Okay, clockwise angles are always negative. The thing what I told you, ABC waveforms, and how they, in phasor diagram, how you have to represent them. Okay, if it is going upward, 30 degrees lag. Okay, 30 degrees, 1 minute, 30 degrees. Here waveform C is there. 30 degrees lead, it is going above. Okay. So C waveform, you see the sentence here. You see the sentence here. C waveform leads A by 30 degrees. So clockwise measurement are leading angle. Anti-clockwise measurement are lagging angle. Anti-clockwise negative angle we write. Negative means lag. Clockwise measurement we write positive angle. So positive means lead. Okay. So you remember this is the phasor diagram. This is the phasor diagram. This is in terms of waveform. I already shown you the in terms of equation how we have to go about it. Okay. Now they may give you some question. Why we are discussing all this? They may give you some question like this. You see here, draw the waveform. Sine wave B lags behind sine wave A by 45 degrees means lagging means you have to start A first, then B you have to start 45 degrees delay. Okay. Now C is leading by 30 degrees means you have to start C before A. You see here, this is the B. Okay, lags behind. In terms of equation, this is wrong actually. In the PPT, you follow the PPT, what I have told you for PPT, that is correct. Okay. Now coming to series RL circuit. Series RL circuit, you can see this is the RL circuit. This is RL circuit. And now the voltage and current. Voltage and current. Which one is lagging? Which one is lagging? You see here, current is on x-axis. Current is on x-axis. And if you see in the RL circuit, we have three voltages. In the RL circuit, we have three voltages. One is supply voltage, voltage across resistor, voltage across inductor. Okay. Now we are doing it in the phasor diagram. Voltage across resistor is taken on x-axis. On inductor is taken on y-axis. And supply voltage comes in the first quadrant. Okay. This is the angle. This is the angle. Now I is the current. I is the current. You can see Vs, voltage leads current by theta degrees, or current lags voltage by theta degrees. Okay. So theta is the phase angle between supply voltage and current. The phasor diagram for RL circuit, series RL circuit is shown here. And if you want the supply voltage, it is nothing but square root of VR square plus BL square. Okay. This is about RL circuit. They may give you one problem. This is RL circuit. Immediately, if you see the RL circuit, okay, RL circuit, you can draw the phasor diagram, and then what all you can give, these equations you can give. Phasor diagram, waveform, okay. So VR and I, current and voltage across resistor, they are in phase. There is no phase difference. 0 degrees is the phase difference between VR and I. You can see both of them are represented on x-axis only. VR and I both are on x-axis only. Phase difference between them is 0 degrees angle. They are in phase. Okay. Now VL is leading angle. So VL is starting before origin. You see here VL, when you measure the anti-clockwise measurement of the angle, VR is 90 degrees phase difference with VR. Okay. VL is 90 degrees plus 90 degrees phase difference with VR. So VL is leading. So the waveform we are taking for VL before origin. VR is starting from origin. VL is starting before origin. Okay. This is the meaning. And now if you draw Vs, it is also leading by theta. It is also, VL is leading by 90 degrees. Vs is leading by theta degrees with respect to origin. Okay. So these are the informations. Now this problem, if you see what they have asked, find the Z value, current value, phase angle, voltage across resistor, and voltage across inductor. Okay. With this one problem, I may wind up this topic. We will see if possibly. RL. Okay. RL is given. 1 kilo and 50 millihenries are given. Supply voltage is 10 volts, and 10 kilohertz means this is the frequency. 10 kilohertz is the frequency. Okay. You can see 1 kilo ohm resistor, 50 millihertz coil, and 10 volt RMS, 10 kilohertz is the supply voltage, and find the Z value, current value, phase angle, voltage across VR, voltage across VL. You can see here itself if I explain, angle is XL by R. Okay, angle is XL by R. So XL means what I told, omega L. Omega means 2 pi F. So F value is given in the question. F value is given in the question. Pi means 3.14. Okay, 2 pi F. 2 into 3.14 into F value 10 kilohertz is given, and that will come in the numerator. 2 pi F L. Okay, L also given in the problem. L also 50 milli is given in the problem. So 2 pi F value L. All you calculate, it becomes XL value. XL by R is the angle. XL by R is the angle. So R value given in the question 1 kilo ohm. Then it will be the phase angle between voltage and supply voltage and supply current is the theta. Okay. So it is very easy to remember. Don't leave. This is very simple problem. One more time I will show in the writing also, in the slide also I will tell. And once you calculate Z value, okay, supply voltage by Z becomes current, and then you can calculate VR is nothing but I into R, and VL is nothing but I into XL. Okay, very easy problem, what we have discussed so far. You are given with RL circuit. You are given with RL circuit. Okay, and supply voltage is there. Supply voltage is there. This is Vs, and this is R value, L value, current I of t. Okay. So what they have given, Vs is, I think 10 volts, 10 kilo Henry's. I will check. So R value 1 kilo ohm is given. L value 50 millihenries is given. Okay. Then find Z value, then current value, theta angle value, VR value, and VL value. Okay, all these are asked. Supply voltage, I think 10 volts and 10 frequency is also given. Frequency is also given. You see the circuit, 10 volts, 10 kilohertz. Okay, 10 volts, 10 kilohertz is given. Volts, 10 kilohertz is the frequency. Now coming to the solution, Z means square root of R plus XL square. Okay, Z means R plus JXL. If you want the magnitude of Z, it is square root of R square plus XL square. First you calculate XL value, omega L. Omega L means 2 pi F into L. 2 pi F into L. F value given in the question. Okay, this is F value. This is F value given in the supply voltage. F value 2 pi into 10K. 2 pi into 10K. And then L value also 50 millihenries. 50 into 10 power minus 3. Take your calculators without fail. Okay, take your calculators. What is the answer? XL will come. XL will come. If XL is there, theta means formula is tan inverse XL by R. Okay. So now calculate XL value, this question mark value divided by R value given in the question 1 kilo ohm, so 1000. Calculate what is the angle theta. Okay. Then current. Current is nothing but supply voltage by Z. Okay. Supply voltage Vs by Z value. Vs by Z value. How they have calculated current, you see. Current is supply voltage by Z value. Supply voltage simply 10. Okay, Z value already in after the final calculation, it is 3295.4. 3295.4. Okay, so 10 by the Z value will come current. Then once current is ready, current into resistance is VR value. Current into resistance is VR value. Current into XL is VL value. Current into XL is VL value. Okay. So very, very simple. Very simple. Now you find out this is 10 by Z value. How much you got Z in the previous here? Z is yet to be calculated. Okay. Once you get Z value, that Z value you will put here. Next, VR is nothing but I into R. VL is nothing but I into XL. Okay, XL you are yet to calculate here. Question mark is there, that question mark also. Okay. Direct formulas, very simple. So once you understand this RL circuit, this is a problem on RL circuit. Once you understand RL circuit, similar formulas for RC circuit. Similar formulas for RC circuit. Okay. RC, what you have to do? This is RL only. You see here RC circuit. RC circuit angle already I told you XC by R. XC means 1 by omega C. Omega means 2 pi F. Okay. And these formulas are same. Z is nothing but R minus JXC. R minus JXC. XC means 1 by omega C. Okay. And based on that, you will have the remaining formulas RC circuit and supply voltage similarly given. And first you have to calculate XC, then Z value, then current value, VR value, VC value. Okay. VR value, VC value. This material I will give as it is. Go through the problems. In the phasor diagram, if problems comes, it is very easy. Okay. What I completed is up to here. Impedance, admittance. Admittance means 1 by Z. Admittance means 1 by Z. Up to here, I have completed till now. Okay, my discussion up to this portion, it is completed. Just 1 minute.